What's up, my quarantine peeps? Coming to you for week 5. I wanted to go over the ideal gas law problem step by step. I think there was some missing of the power and the simplicity of the ideal gas law last week. It should have made things a lot easier to solve those problems. I know there were some new things in there like the R values, so we definitely want to take a look at those. But I want to just walk you through an ideal gas law problem step by step all the way through. I'm going to put this slideshow at the bottom as well, so you have something you can print out or go back to if you need to in the future. So let's get into this bad boy. All right, so remember, you have these steps to problem solving that we should be doing pretty much every step of the way. Every problem we do, we should be looking through these steps. We want to give a list of your given and unknown information. That's going to help you figure out what gas law. As you're writing down that information, if there's anything that is given to you in Celsius, as far as temperatures go, remember every gas law equation to plug temperature in, it must be converted to Kelvin first before you use it in the calculation. After you convert that temperature to Kelvin, go ahead and look at your variables and see what you got. Do you have two pressures and a volume and it's asking you for another volume? Well, then you're probably going to use Boyle's law. You have one set of conditions, a pressure, a volume, and a temperature, and they're asking you for an amount. Then you're looking at an ideal gas law situation. Once you get that original equation written down, and you may be asked to write down the name of it, Boyle's, Charles, Gay-Lussac, combined, or ideal gas law, go ahead and show the rearrangement. You can do this in two ways. You can put the values in with units and then solve for the unknown. Please don't change the unknown's variable to X. You guys have a propensity to do that. There are variables assigned to every measurement already. Just use those, P, V, N, and T. Or you can rearrange the letters, which I think is actually faster and more expeditious. I know that some of us have an allergy to rearranging letters like their numbers, but it works. It's fast. It's much less to keep track of and much less likely to make errors if you rearrange the variables and then plug your values in. Once you get your values plugged in, make sure you're keeping units all the way through, and then do the math. And then you're going to round your numbers to the right number of sig figs. There were a few questions on that last week as well. So we're going to go through that when we get to the point in the problem we're going to go over together. So here's our problem. The ideal gas law. We know it's an ideal gas law because there's only one set of data. It says we have a 0.625 mole sample of a gas, has a volume of 12.5 liters at 105.0 kPa. That's kilopascal. That's a pressure. I would really make sure you're paying attention and you know the units. Moles go with N, liters with V, kPa with P, and it's asking for the temperature in Celsius. Well, that's nice, but we're not going to be able to find Celsius directly from the reaction equation that we're dealing with. When we do this calculation, it's going to give us a Kelvin temp that we're going to have to convert back to Celsius, and we'll talk about that when we get there. So list the given and unknown information. So I just go through typically and label everything in my problem. 12.5 liters, that's my V. 105.0 kPa, that's my P for pressure. Here's my mole amount and then my temperature. And it's asking for temperature in Celsius. It's also a good idea to give yourself a list down here, because now you're going to see P, V, N, T, and you're thinking, okay, what gas law do we need if we have P, V, N, and T? No, there's not two P's or two V's or two T's. It's all one set of data. That should lead us to Pivner. And we're obviously going to rearrange and solve for T. If you want to use the R value that you're probably most comfortable with or most familiar with from what we've done so far, which is 0.0821 atmospheres liters over moles Kelvin, if you want to use that R value in your calculation, that's fine. You just need to convert your kPa to atmospheres using dimensional analysis real quick. Super easy. Plug in the one you know, 105.0 kPa, and then multiply by 1 atmosphere over 101.325 kPa. So this is the equality. 1 atmosphere is 101.325 kPa. They're the same pressure. Make sure your kPa's cancel. You'd be left with 1.036 atmospheres. And then you could use your 0.0821 if you really like that R value. I would say, in this case, since we have kPa, if we solve for R, we find R or calculate R, you can go back and look because we have a whole list of these from last week. If you plug in standard pressure in kilopascals, which is 101.325 kPa, standard molar volume, 22.4 liters, 1 mole at standard temperature, 273 K. Do the math, 101.325 times 22.4 divided by 1 divided by 273. We get this 8.314 number. That way you don't have to do any extra conversions. You just plug in the R value in kPAs. Now, we know we're going to use Pivnert. We know we need to solve for T. So undo what's being done to it. Get rid of the N and the R. So N and R are multiplied by T, so we got to divide both sides. As you can see on this side, the N's are going to cancel, the R's are going to cancel. That's going to give us our new equation, which is PV over NR. So P times V divided by N divided by R gives us our temperature, and that's going to be in Kelvin. All right, plug your numbers in. Be very careful, double check, make sure your numbers that are going into the equation are the ones that were given in the problem. Make sure they're going into the right spot. Make sure you're keeping all the digits. Make sure you're keeping the units. Very important, especially for this next step. When you're going through and doing the math, you have to cancel your units. If you don't write units in there, you're not going to know what to cancel. So you can see our kPa and the pressure cancels out with the kPa and the R value. That's why we have to pick the right R value that has the same pressure unit as the given pressure, or we've got to convert our pressure so that it matches the R value. Liters and liters, they cancel. Moles and moles cancel. We're left with Kelvin. If we do the math here, we get 252.59 K. 252.59 K. That's good, but it asked us for the temperature in Celsius. So remember, to get Celsius from Kelvin, we subtract 273. Gives us negative 20.414 degrees Celsius, 20 below. Now, if we look at the sig figs up in our givens, there's 3 digits here, 4 digits, and 3 digits. When we go and round our answers to significant figures, you always move from left to right. Since the very first number we hit is a non-zero, we're going to keep that digit. That's our first significant digit. Every digit after that is significant until we run out of numbers to keep. This number is significant, and so is this one. So we're going to use the 1 in the 414 to round 20.414 to 20.4 degrees Celsius. Don't forget to keep the negative in there. If you have any questions on sig figs, I'll post a couple videos. I know Tyler DeWitt has a whole bunch of them on there as well. I'll post links to each of the tutorials you would need for significant figures and anything with dimensional analysis. If that becomes a problem, just put comments in the class notes section and I will either make something or I will find a tutorial to post up for you. You guys have been doing a good job asking questions. You can send private messages through Classroom on the assignments. You can post to the Classroom comments on the assignments. And week 5, this week, we will have a Q&A discussion thread as well. So use this as you go through the end of week practice problems that you're going to submit electronically. Please double check your work, make sure you're showing everything, and make sure you're taking a clear picture of your entire document before you submit it. Make sure that it's something I can read and see. Double check before you submit it and turn it in. Hopefully you're doing well. Remember, this R value is a set of conditions we're going to compare everything else to. So this should make things a heck of a lot easier. We have one pressure, one volume, one mole amount, one temperature. You just plug them in anytime you have one set of data, rearrange for the unknown. If you forget what R is, rearrange PV equals nRT for R. You get PV over NT. Plug in the standard conditions. 1 mole, 22.4 liters, standard pressure at 273 K, and you'll get your answer for R. Look back at the notes. Again, I'll post these slides for you as well. Stay healthy. Hope to see you all soon. Be strong. Get better every day.